Yeah, so last time we talked about the different evaluation metrics that you probably already knew about: accuracy, precision, recall, and the F1 score. So that was just probably a recap. Today we want to build two classifiers and also do an exercise where you can choose between those two, or if you have the time or if you're willing to do, you can also compare the results of those two. The first one is a logistic regression, so we will train a model ourselves, and then again we use a pre-trained model from Hugging-Place transformers, and we'll see how the results compare to each other. Okay, so let's go ahead. So what is the goal of our pre-trained model here? The goal is, again, we want to do classification, but this time we train a logistic regression model for classification. And the steps are pretty much very similar. So first of all, we know the data set. Data set has to be labeled, of course. Then we have to do pre-processing again. This time we do binarization and we do vectorization. No worries, I will get into that in the next slide. Then we have to train the model because it's not trained; it haven't been trained yet. Keep in mind, if you train a model, there's always the possibility or the danger of overfitting. So we have to take that into consideration and take a look at the results if we have a problem of overfitting here. For training, we can use, again, Python libraries. We mostly use sklearn, and then we have to evaluate the model using the same metrics that we have learned last time, or that we are also using for the pre-trained models. Yeah, but let me quickly explain or define the vectorization, what it is. So yeah, what is vectorization? First of all, we load our data set. So the data set is the text, like in our last case, that was reviews or any text that we can upload. We then use something that is called TF-ID vectorizer to find out how often does a word appear in our text. That's the first one. Or is this a word that is rare in general? Or is this a word that in general occurs often? Like, yeah, basically all type of words that we use very, very often in text, and it is not specific to text. And then we give weights to these words. So we give a higher weight for words that appear a lot in the text, and we give lower weight if it's a word that isn't very rare in general. Then, you already have seen that we use stop words to remove the most common stop words we know, because these don't help our model, right? And then we use max features to only focus on the most relevant words in our reviews, because yeah, the larger the data set, the more or the higher the number of words in it that occur. So we only want to focus not on all, but only the most relevant words. And we can specify a number for that as well. It's a parameter. And that is the concept of vectorization, which we will see in a minute. Okay? This is just a little background information. So I would suggest we do that together before we move on to number. Okay. So we're gonna import the libraries one by one, as soon as I realize which libraries we need, because I don't know yet. But of course we need pandas again to first import our data. The data set we want to import is called, it's the IMDb data set. So maybe you know this site. It's a website that is basically scoring movies and TV shows, and of course there are also reviews by users of this website, and you can download those reviews. I think I just downloaded a snapshot, but we can take a look at it. So let's first load this in a data frame. Again, call it however you want it. I call it df, and then please input the file path to it. As you could see, I downloaded it in a folder called data. So before we move on, let's quickly take a look at the data. Yeah, it looked like it's a snapshot. It's 50,000 reviews. And we only have two columns, the review and the sentiment of the review. And we see the sentiment is in text and it's lowercase. Yeah, it's something we have to keep in mind. What we could do is, because I think I showed this last time, let's quickly, just to get a little bit of better view, a little overview about the data, let's quickly check how many positive and how many reviews we have in our data set, just to see if it's imbalanced, meaning that we could have a problem because one class, positive or negative, is way more, there are way more occurrences of one class than the other. We don't want that. So let's quickly check if the data set is like nearly balanced. Okay, there are a lot of ways to do this. I would suggest maybe to draw some plot. Let's use a pie chart, for example. And to use that, we first need to count how many positive and how many negative reviews we have. So let's do that first. Count occurrences. I save it in, for example, sentiment counts. So we need, yeah, that's the column name. So we use the column name and then we just use the function value counts, which is the function from pandas to count the values. And then let's just see what we got. Okay, mini balance. So I don't think we need a chart for that. But we can do it anyway. But yeah, somebody has drawn a sample here, I would guess. Yeah, let's just to warm up, we try to draw a pie chart. Okay, you can of course draw another chart if you like. So I'm just commenting a little bit what I'm doing here. I'm making the pie chart a little larger, or I make it square, so make it 6" by 6". And then we can also add a nice title. I like to format my titles. I don't know, it's just something I like to do. So, and it's not, yeah, sometimes it's not very self-explanatory. I can get to that in a minute. Or if you're interested, I can explain that in a little bit more detail. But let's first do title. I want it to not be centered, but I want it on the left side and do a smaller font size, and then I'm gonna go into the title. Then I format the title because I want it to be partially bold. So let's do, how about IMDb sentiment. Like that. Okay, that's the title. And then we can draw our pie chart and we just need the values of sentiment counts. We need some labels. We can use, as you can see, I can't see. Let me quickly check this again. Sentiment counts. As you can see, we can use this label from sentiment counts, positive and negative, to use that as a label. So it's sentiment counts dot index, which refers to this index here. That's the index. So we can conveniently use that as our labels. And I think that's it. Well, we can You can define a start angle. I mean, that's also what very subjective. However, you like that best, and then we show the pie chart. Yeah, we need to import it. Okay, go. Oh, yeah, looks good, but maybe let's also have the percentage values here. Let's do 1 decimal. Um, add for format. And there's a percentage missing. We really mean that we really haven't had to do this, but yeah, I mean, now you have it in your example, just in case. It's because most of the time it's pretty useful to do a visualization before we start. But in this case, when we have exactly the same number of positive and negative residues, we really didn't need to do this. Anyway, let's save it. At least we have a good example for a nice headline. Our next step, the next steps involve the pre-processing of our text data, and we do exactly what we have seen just seen in the slides. So first we're going to split our data. We're going to split it into features and our target variable. In our case, we just have 2 columns, so that's pretty easy because we have just the review and we have the sentiment. Okay, the sentiment is obviously our target variable. Then we probably have to do map it because, as you could see, well, you can't see it anymore, but the sentiment was text, so it said positive or it said negative. Yeah, it is not something an algorithm like logistic regression can work with. Logistic regression needs a numeric target variable, so we have to map it. We can keep this easy. We just map positive to 1 and we map negative to 0. So pretty easy. And then we have to split it for training and testing so that we have training features and target variable and testing features and raw variables. And then we do this text vectorization that I just explained in the last slide. Okay. And after that, we can train up more. But that's the pre-processing we have to do first. So let's first split the data, which I said is pretty easy because we have just 2 variables. So I basically, as I already have done last time, I call my features X and I call my target variable Y. So the only feature we have is our review. So the review text of the users. And the only target variable or the target variable we have is of course the sentiment. But as I said, it's text, so we have to map it to make it numerical. We do this using map. That is pretty easy to use. You just do a dictionary and we say, hey, if it's positive, please make it 1. And hey, if it's negative, please make it 0. That's it. Of course, we're going to check this. If this is correct, always a good idea. And as you can see, now we have 50,000 rows and 0 and 1. And it should be, again, evenly distributed. That's good. I'll quickly save it. And now, I don't know why I put this here. We first need to split data into train and test. I'm also a big friend of commenting a lot. Don't ask me why I put this in uppercase. I just like comments in uppercase because it stands out to me more. If I'm using notebooks, I put all my explanations in the markdown, and then I just use uppercase for especially when I'm writing functions, just to see what happens. And I'm most of the time, again, especially with functions, I start with the comments. So I'm writing not the function, I'm writing the comments of the function first, so that, yeah, sometimes stuff stuff is happening, so I have to come back to it, but then I have at least an outline what I'm gonna do. Okay, I think we have already done this before. We need training features. I call them X-train. We need testing features. I call them X-test. And respectively for our target variable, I call them Y-train and Y-test. To do that, we need train test split. Of course, we need to import it first. So let's say from sk learn model selection. Import train test split. And as I already know, we're going to use a logistic regression. Let's import that as well. And you know what? I already know we're going to evaluate our predictions. So if you have your notebook from last time open, you of course can just copy paste it, because we are using the same metrics again. So let's import the following metrics from sklearn metrics. We're going to import the accuracy score. We're going to import precision, or we're going to import the recall score, and we're also going to import the F1 score, and we draw let's do a confusion matrix as well. Then we should be all set. All right. So, train test split. And we use our features, we use our target variable. So how do we split? Let's use 80% for training, meaning we have 20% left for test. And of course, we're gonna give a random seed just in case we have to rerun the code. So that's it. Okay, let's save real quick. And now we have to do text vectorization. Okay. So again, we use this EFIB vectorizer. Of course, we need to import it, so let's import it in a bit. It's a package from sklearn again, feature extraction.txt is the name, and this TFID vectorizer converts text into a vector, specifically in a vector called TF-IBF. That means term frequency inverse document frequency. And as you saw in the slide, this TF-IDF gives a weight to each word based on its frequency in the document versus its rarity across all documents. So lower weight for words that are that occur generally very often. And yeah, as I said, this helps emphasize important words while reducing the impact of commonly used words. We also have to remove the stop words because they don't add meaning to our reviews, and we do reduce the number of features we want to use to, let's say, a couple of thousand relevant words. Let's do 5,000. Of course, you can play around with this number if our predictions are not very good, but let's start with 5,000. That's not too much, not too low, I would say. Okay, so let's first convert reviews into numerical format, meaning features. I initialize it and I call it vectorizer. To use the vectorizer, again, it's called TFID vectorizer. We do stop words, and because the reviews are in English, we get rid of English stop words. And we have a maximum number of features. Let's do 5,000. Again, before we can use it, we have to import it. So from sk learn feature extraction dot text import the TFID vectorizer. Oh, after we have done this, we have initialized it. Now we're going to use it. We use it with calling fit transform, and fit transform transforms our features into what is called a sparse matrix representation. So you probably know what a matrix is. A sparse matrix is just the usual matrix, but we get rid of the non-zero values. Why we do that? Because as you might guess, in a review, when we have 5,000 words, a lot of these columns will be empty because most words don't occur every time. All right. So that would take up a lot of space, which we don't need because it slows down our model. So that's why we use a sparse vector, and it will be a lot smaller. How much smaller we probably see when we trained it, or when we have used fit transform on our features. So let's do that. So let's transform and fit in train features. This is done to learn basically the vocabulary of our text. All right, so let's now learn the vocabulary of our reviews. So I saved them because now in Xtrain we still have our real reviews, our words in it. Now we have to vectorize it. So I'm going to save it in another variable, and I call it Xtrain vector. I don't want to override my original text. Why I want to do that? Because sometimes after, again, if you evaluate your model and you, let's say, yeah, your accuracy isn't very good. So maybe then you want to take a look at a couple of reviews and just to take a look at where was your model wrong and why. So you read a couple of those reviews. But in order to be able to do that, to see the predictions, the wrong predictions, and the original text, you need the original text. So I don't want to overwrite it because the original text is still here in the Xtrain. So that's why I don't override Xtrain, but save it in Xtrain vector or in any other name you want to call it. So let's use our vectorizer, and we use the fit transform method on Xtrain. Okay. And then slightly different, our test features, X test vector. Again, I'm not gonna override it. So let's do that. Well, hopefully, and shift this out. X-text. It is an X-text. Test. Okay. Maybe we can take a look at it. Okay. So you see, it specifically says here is it's a sparse matrix, And now you see the difference between a matrix and a sparse matrix, because we have, these are the dimensions of the matrix. So it's 40,000 times 5,000, because we have limited to 5,000, right? So if you would do the math, that's 200 million, right? 40,000 times 5. Yeah, that's 200 million. But we only have 2.8 million rows in it. And why is that? Because it's sparse. Like, we only count the non-zero values. So it's 200 times smaller because we use the sparse matrix. So that will give us a lot more efficient, or that is a lot more efficient, okay? So that's why we do that. Good. Save it. I think we should be ready for training now. Yeah, we don't need to split. I don't know. I've got here. It's warm. We just need to fit our logistic regression model. Okay. Again, this is training again, but this time we don't learn the vocabulary of the text, but we learn the relationship between the vectors. Okay, that's the that's why the purpose of this training now. Now I lose LR for logistic regression, so let's initialize logistic regression. I think we have already imported. So we initialized it. Now we can use the training method, which is again called fit, and we use our train vector and our train target variable. If we have done that, we can make predictions, and let's save the predictions again in ypred. And to do predictions, we all predict using our test vector. Again, text test. We quickly go over it again. We initialize logistic regression. We train using the training vector data and our target data. And we make predictions using our test vector. Should be correct. And then we can evaluate. Let's use all the metrics we have imported. So we had accuracy, we had precision, the recall, and we had F1, and let's also do a confusion matrix. Okay, to get the average accuracy, we call accuracy score, and we call it with our test and compare it to predictions. And for that, we need precision scope. And we need recall score. F1 score. And for the confusion matrix, we need confusion matrix. Also test and prediction. And then let's print it out. Accuracy. And then it's accuracy. And we are. Let's format it so that we can see it in as decimal percentage. Let's do copy paste. That's the precision. That's the recall. That's the F1 score. Where is recall? F1 score, and then also we need the confusion matrix. Just train the divider. Okay. And let's see. With an eye missing. Okay. Pretty good. It's pretty good. 88% precision recall. F1 score all around 88, 89%. And here, seeing the confusion matrix here, we have some pretty equal false negative and false positives. Now, what I promised to do, let's take a look at a couple of those wrong predictions just to get a sense of. I mean, this model is good, but obviously it can be improved. So let's just take a look at a couple of reviews where the prediction went wrong. So maybe we can find a pattern. So how do we do that? There are lots of ways to do that. So I'm just thinking of a very efficient way. Obviously, I want to create a data frame, and I need the original review. I need the actual sentiment, and I need my predicted sentiment, and I also only must see the examples where I went or the model went wrong. So let's first create a data frame for wrong example. So let's call them wrong examples. And it's a data frame. And it's a data frame. And the data frame consists of, we want to see text. The text is our review. And as I said, we can find the text because I haven't overwritten it in our test data set. We need the actual sentiment, which is saved in our, again, test data set. And then we just need our predictions, which we have saved in our prediction. ypred. There's a comma missing. That's it. Now we have it in a data frame. Let's quickly check that. That is correct. It's looking good. So we need to filter it, but I have no idea what the syntax is. So basically I use ChatGPT as well. What is the syntax? You need to use abundance and then indicate display max columns and set it to true. Okay, or false. But yeah, you can ask ChatGPT. You know the exact wording display. Max, what do you say? Yeah, that's my with. Okay. Okay. That works. Yeah, that works. Okay, that's good, but yeah, we have our whole test data set. We don't need that because yeah, we only want to see those. What is 523? So let's filter all data frame. Filter wrong predictions. So that's long examples. And then well, examples where the column actual and the column prediction don't match. Yeah. Yeah, so now we filter only those where actual and prediction did differ. Let's look at the first one. Also, this film was made before my mother just Huh? For the first one, the prediction is correct, I would say. This is a positive review. How is that a negative review? You see that? Why is this labeled negative? That's a mistake. Let's take a look at the second one. Yeah, second is a mistake. That's correct. But the first one isn't a mistake. It would be interesting why the second one. I would have guessed the second one is pretty easy to catch that it's a negative prediction. Maybe the words that were indicating it, like rather stupid or hardly even loved, is not interpreted as negative. I don't know. Using transformers, we already did that rudimentary or a simple case of that in our first lecture. So same goal here, but this time we use a pre-trained model, of course, or one of those pre-trained models for text classification, but the steps are pretty much the same. So we load a labeled data set, we have to do some pre-processing. Then we don't train a model, but we load a pre-trained sentiment analysis pipeline, and we're gonna evaluate the model again using probably the same metrics, right? I think I have already mentioned the word pipeline in our last lecture, so let me quickly just give you a little bit of theory or background information, what a pipeline is, what the purpose of the pipeline is, what you can do with it, and before we build one ourselves. So first of all, we're gonna load our data. Of course, exactly like with a not pre-trained model. So maybe a file, or also can be like user input. And then we do some pre-processing, but the pre-processing here is again tokenization, it's lemmatization, it's lowercasing, but also stop word removal. Then we load one of our pre-trained models, so a pre-trained model of our choice, which is, as we have seen, oftentimes a fine-tuned model, fine-tuned for a specific task or fine-tuned for a specific language. And then we let the model make predictions about the sentiment of our text. And finally, we display the output, oftentimes along with how confident the model is. There's a confidence score. We can put that out as well in our results. So that's basically it. That's enough theory again. So let's try to build one together. And then after that, we can jump into an exercise where you can do this on your own now. You are more than equipped to do this now. So let's go back. We import table and we import libraries. We need import pandas. What else? We need definitely transformers, which should work on all your notebooks. Transformers import pipeline. And what else? We need to enter split, of course. Split our data. And then we need all these metrics again. Accuracy, precision, recall, and F1 score, and of course the confusion matrix. All right. Okay. So we're gonna compare our models now, meaning we use the same data set. So put it check. All right, here it is again. And now we need to pre-process, meaning we need to split and we need to map again. So basically exactly the same. If you have your other notebook still open, you are free. You just copy paste it. Again, we need to map it to the correct values. The positive is again 1, negative is again 0. And then now we're gonna train the model. We use probably the distillable base uncased model again, the fine-tuned one for English. So yeah, I think that was the one we already used last time. But before that, we need to train. We need to split. So again, X train, Y test. Let's use exactly the same test size so that we can compare the results. Next thing is we need to define a model. Let's copy it. Yeah, I think that was the one we used last time. Okay. So now we're gonna create a pipeline. Already defined the model. So to create a pipeline, we load it. and it's a sentiment analysis pipeline. We're going to set truncation to true just because the reviews are quite long. We use our model, and yeah, here please, because if you don't have the latest OS, so if you're on a Mac and you don't have the latest OS, or if you don't have a Apple Silicon chip, don't use device MPS. Okay, otherwise it won't work. And if you have used it and it doesn't work, you have to manually set it back by using device equals -1. Okay. Yeah, so let's load the model. True is not defined, yeah, because it's uppercase. All right. Yeah, now we can make predictions. So the we're gonna store, of course, the predicted labels again in YProt. It will be 1 for positive and 0 for negative, but we can also save the confidence scores along with it. Maybe we'll use it afterwards, because then if we take a look at the reviews where we went wrong, we can check how confident the model was at those predictions. So it's not a bad idea to save them alongside. We have to, in this case, we have to initialize a list where we save our predictions. We also have to initialize a list where we save our confidence scores. And then we're gonna loop over. So for text in X test, so we're gonna loop over our test data set. We're gonna make predictions. Take them in result. And we make predictions using our one classifier and handing over our text. Only the first column. All right. And then we're gonna append our predictions, because we have initialized an empty list, and now we are getting predictions for the sentiment, and we just keep appending it until we have looped over the whole test data set. Are we doing this here? Because the predictions of this Hugging Face model are in uppercase positive or negative, but we have mapped our sentiments to 0 and 1. So we have to map the predictions as well to 0 and 1. Otherwise, we can't compare them, right? Then we're also gonna append the confidence scores by using append, using the results, and the confidence score is saved in a column called score. Right. This is definitely slower, a lot slower than training a model like logistic regression. You can already tell, I think it only took 2 or 3 seconds. But here, improvements using their Apple Silicon chip in training models or making predictions. What we could already calculate our scores. I don't really want to practice this again. Let's copy paste that. Wait. And it will take a little time. Okay. Imagine this is not a big data set, right? We have, how much was it? 50,000 reviews. That is very small. Look how slow it is. And it's running locally, right? We downloaded the model. Yeah, what you could do if you, yeah, if you like to do something like that, you could use Google Colab and just use the free GPU. I think you have 1 hour per day. And then, of course, you have to change the device to GPU. But just to make a comparison, if that helps, that would be interesting.